Okay, so we have one more rule to cover, and then we'll do some work on some examples. Let's see, I'm not getting good. There you go, that's a little bit better. Okay, so the next rule we're going to cover is something you probably noticed in the last video, where we took a derivative of a function of the form f of x equals a0 plus a1x. Okay, and we combine the constant function rule with the power function rule. Okay, and using both of these together, we came up with something called a linear function rule, which says that f prime of x equals a1. And we went through, piece by piece. We applied the constant function rule to a0, then we applied the power function rule to a1 times x in order to get this result. Now, if that, so we were able to apply two different rules on two different terms. Okay, this leads us to our next rule, which is kind of an obvious outcome of that application, and this is the rule for sums and differences. Okay, and what this rule says is simply that if you have f of x equals, say, a term g of x plus or minus a term h of x plus or minus a different term I of x plus or minus, however many terms in your function you have, that the derivative of that function is simply applying the necessary rule to each of those terms individually. Okay, so it doesn't change the general functional form any, because again, you're just applying the appropriate rule to each term individually, but the function's integrity stays intact. Okay, and again, this is sort of an obvious outcome of applying the constant function rule and the power function rule to that linear function. Okay, now let's work on some examples. Okay, we're just going to go over a few examples and then move into our next topic in our next video. Okay, so let's assume, so we're going to apply everything necessary in order to find the slope of a particular function. Let's say that we have f of x equals 4 plus 3x squared. Okay, so we have a constant. We're going to apply the constant function rule, and then we have a regular term with x in it, with the variable x in it, so we're going to apply the power function rule to this. So this gives us f prime of x. We know that the derivative of a constant is 0, plus applying the power function rule just to this term, we get 2 times 3x to the 2 minus 1. Okay, and of course this equals, okay, so the 0 goes away, so f prime of x equals 6x to the first power, because 2 minus 1 is 1. So the derivative of this function right here is 6x. In other words, the slope of this function right here. Now recognize this is not a linear function. This is a nonlinear function. Okay? So the slope of this nonlinear function is 6x. Obviously, then the slope is going to be different depending on the value of x. In other words, if we were to graph this linear function, which we won't do right now, but if we were to graph it, if I picked any point on that graph, on that function, and I wanted to find the slope at that point, I would simply plug in that value of x into this derivative function and calculate it, and it would give me the slope of that function. Let's look at another one. Let's say we have f of x equals 4 plus 3x plus 3x squared. So now we're going to apply the constant function rule, and then we are going to apply what you could call the linear function rule, but it could also be the power function rule, and then we'll apply the power function rule. So f prime of x, the slope of this function, that would be 0 according to the constant function rule. That would be 3 according to the linear function rule. And then this, according to the power function rule, would be 2 times 3x to the 2 minus 1. So then f prime of x, in other words, a derivative of f with respect to x, would equal 3 plus 6x. So this is the slope of that. Okay, let's do another one. Let's say we have f of x equals 17 minus 3x plus 4x cubed minus x to the 4th minus x to the 7th. So what is the slope of this function? In other words, what is the derivative of that function with respect to x? So f prime of x, then, of course, that's the constant function rule applied, would equal 0, minus the linear function rule applied would equal 3, plus, now we're going to apply the power function rule 3 times. That would be 12x to the 3 minus 1, minus 4x to the, 4x to the 4 minus 1, minus 7x to the 7 minus 1. And of course, simplifying, we get negative 3 plus 12x squared minus 4x cubed minus 7x to the 6th. Okay, and that is the slope of that function right there. So if we were to graph that function right there, which is an extremely complicated function to graph, and we won't do it, but if we were to graph that function right there, we could find the slope at any point on that function by using this equation here and just plugging in any relevant value of x. A number would be calculated, and that number would be the slope of this function at